Earth was not always a world of only Homo sapiens. From about 300,000 years ago until just a few thousand years ago, multiple human species lived across the planet. Neanderthals, Denisovans, Homo floresiensis, Homo naledi, and more. So the question is, why are we the only ones left? Let's treat this like a suspenseful story, evidence, clashes, and survival by chance. First, who are these other humans? Neanderthals, found across Europe and parts of Asia, stocky and short, with large noses and bodies suited for cold. They were skilled hunters and lived in caves. Denisovans, a mysterious group known mostly from DNA. Their genetic traces appear in some modern Asian and Oceanian populations. Homo floresiensis, the Hobbit, a small-bodied species discovered on the Indonesian island Flores. Others, Homo erectus and several regional groups, still under study and reclassification. Now the main point, how did they disappear? There isn't a single cause, think of multiple overlapping explanations, and different regions had different stories. Competition and resource pressure. When Homo sapiens left Africa, roughly 60,000 to 50,000 years ago, they entered lands already occupied by other human species. Competition for food and living space likely followed. Sapiens had flexible toolkits, wider social networks, and strategies for long-range hunting. Smaller, isolated human groups may have declined under this pressure. Disease and biological vulnerability. When distinct populations meet, they exchange pathogens. Homo sapiens evolved immune adaptations in Africa. When they moved out, they carried those pathogens to other groups that lacked immunity. History shows disease can decimate previously unexposed populations, and the same likely happened to several small human groups. Climate change and environmental shocks. Earth's climate has repeatedly swung between colder and warmer states. Glacial advances and retreats, sea level changes, and shifting habitats would have hit small, localized populations especially hard. Species confined to narrow ecological niches, like Homo floresiensis, were particularly vulnerable when their environments changed. Genetic mixing. Traces still live in us. Extinction isn't always total disappearance. Neanderthals and Denisovans interbred with Homo sapiens. Many non-African modern humans carry about 1 to 2% Neanderthal DNA. Some populations in Oceania show Denisovan ancestry. In that sense, some other humans live on within our genomes. Population size and social structure advantages. Homo sapiens tended to form larger networks with complex social structures, language, cooperative hunting, the ability to transmit cultural knowledge rapidly. These advantages improve tool development, resource sharing, and adaptability. Small, fragmented groups struggled to match that social and technological flexibility. Chance and catastrophic events. Sometimes luck decides. A pandemic, volcanic eruption, sudden climate event, or other catastrophe can wipe out a small population while leaving larger groups intact. Such stochastic events likely contributed to the final disappearance of some species. So what's the takeaway? There wasn't one single cause, but a cocktail. Competition, disease, climate change, genetic mixing, social advantages, and unlucky historical events. Some species went extinct as distinct populations. Others partially survived through genetic assimilation into Homo sapiens. Our success wasn't solely due to one advantage. It came from adaptability, social complexity, better technology, and some fortunate breaks. One final thought. History reminds us that no species is guaranteed permanence. Today we dominate the planet, but climate change, disease, and ecological risk still threaten us. The same forces that removed other human species could, if ignored, threaten our future. If we learn, adapt, and cooperate, we can continue. If we don't, we might one day be a footnote in the fossil record too.